Hello, I am Dr. Gesoğlu. I am going to present the paper Enhancing High-Speed Penetration Resistance of Ultra-High-Performance Concrete by Hybridization of Steel and Glass Fibers. This study actually prepared in Materials Journal and it has recently been published in Materials Journal. And I would like to thank my colleagues, Dr. Muhyiddin, Dr. Yardım, and Dr. Koradi for your valuable helps. Ultra-high performance concrete is very important and very popular nowadays. It has distinctive properties such as high compressive and flexural strength, but it is brittle. To overcome this drawback of brittleness of this concrete, we need to add fibers to improve ductility and to make it more resistant to impact by means of using fibers. The objective of this study is as follows: to assess the performance of hybrid fiber reinforced ultra-high-performance concrete under projectile impact, and to compare mono and hybrid fiber types, and to use numerical simulation to validate test results. In this study, a total of 22 concrete mixes were prepared. The reference concrete is called plain, and then single fiber and dual fiber types have been utilized to make the concrete mixes. The produced concretes were tested under compressive and flexural strength, and to determine fracture energy, it has been tested under 3-point bending, and it has also been exposed to projectile penetration test to see the depth of penetration. Moreover, the test results have been simulated by means of Elastina program to model the validation. The water binder ratio of the concretes is constant at 0.195, a total of cement content and silica fume of 960 and 240 kilogram per cubic meter respectively have been utilized. The fiber volume were changing from 0.25% to 2%, and for dual use of fibers, for example, the designation is as follows: MSF, HSF 2% means 1% microsteel fiber and 1% hook steel fibers are incorporated in this mixture. This photo shows the types of fibers that were incorporated into the mixtures. Figure A shows micro steel fibers. This one shows hook steel fibers, and the last one shows the glass fibers. The testing of the concrete mixtures in the hardened state were performed by means of an Instron machine with a capacity of 250 kilonewton, and the 3-point bending and fracture tests were conducted by means of closed loop operation. This test setup shows the projectile penetration test. As you see, the test results have shown that plain concrete reached a compressive strength of 137 megapascal. By using hybrid fiber of microsteel and hook steel fibers, the strength reached at most 169 megapascal. The order of the beneficial effect of fibers is ranged from microsteel fiber, followed by glass fiber, and the high hook steel fiber on impact strength. This, of course, has been was observed in compressive strength and flexural strength as well. The overuse of plasticizers, spare plasticizers, in the case of hook steel fiber mixed concretes and trapped air were observed that eventually lowered the compressive strength. This graph shows the variation of the compressive strength of the 22 mixes, as you see, plain concrete and 1% steel fibers, 1% micro steel, 1% hook steel, and 1% glass fibers. The flexural strength, in other words, modulus of rupture, was also tested. The plain concrete reached a value of almost 6 megapascal. By using hybrid fiber, this is also almost doubled to 13 megapascal. It indicates almost 100%, 125% increment in the flexural strength. Hook steel fibers showed best crack bridging and anchorage, so it increased the flexural strength more than the micro steel fibers. This shows the variation of the modulus of rupture, and this figure shows flexural failure of plain concrete, while this shows the flexural failure of fiber reinforced concrete. As you see, fiber reinforced provides bridging and anchorage that prevents the fracture of concrete. Plain concrete has the lowest flexural strength, while the micro steel and hook steel fiber has reached the highest strength at 2% fiber content. Similarly, fracture and energy and ductility were measured under 3-point bending. Plain concrete reached a value of 100 Newton per meter fracture energy, while at 1% micro steel fiber and hook steel fiber, the value of fracture energy reached 5,800 Newton per meter. So steel fibers increased post-cracking and energy absorption ability, and therefore the fracture energy of the concrete with hook steel fiber and micro steel fiber were almost reached almost 8,000 Newton per meter fracture energy. The value of plain concrete in this case is lower, and hook steel fiber at 1% shows this black hole. It is when the hook steel fiber is added to the mixture, fracture energy increases rapidly. Also, penetration resistance test results have shown that plain concrete has a depth of penetration only 24%, but by the addition of micro steel fiber and hook steel fiber together, this value decreased to 16.5 centimeter. That indicates up to 32% reduction in the depth of penetration. That indicates the very favorable effect of micro steel fiber and hook steel fiber. So, but steel fibers seem to be more effective than glass fibers. This photo shows the depth of penetration test results and the crater area. As you see, plain concrete has the highest value of depth of penetration associated with the highest crater area. By the addition of fibers, especially by the use of hook steel fiber and micro steel fiber together, both depth of penetration and crater area decrease significantly. The effect of steel fibers is more favorable in crater area, as you see. This figure shows 3 parameters simultaneously: characteristic length, crater area, and depth of penetration. Plain concrete has a crater area of 49 centimeters square. Again, by the use of steel fiber and micro steel and hook steel fibers together at 2%, this value decreased to 52 centimeters square. This indicates 88% reduction in the crater area. It seems that crater area is more sensitive to fracture toughness, as you see. Also, numerical simulation of the test results have been conducted by means of LS-DYNA modeling. The experiments were validated by this modeling. The error range by the numerical and test experimental results is ranging from 3 to 13%. This figure shows the mesh and strain contour from simulation. And as you see, this figure belongs to plain concrete, and this belongs to fiber reinforced steel and macro steel and hook steel fiber reinforced concrete, and the figures under each one shows the numerical simulation. Also, to estimate the depth of penetration, there are some models in the literature. This figure shows the estimation capability of these models presented by different researchers and some standards. Also, figure contains numerical and experimental results. As you see, numerical and experimental results are well agreed, and the estimation capability of the proposed models in the literature are very low. The key conclusions of this paper is as follows. Using a combination of fibers improved the strength values, which subsequently lowered the drop values. The use of both long and short steel fibers together demonstrated the most effective performance in reducing the damage caused by projectile impacts. The use of both long and short steel fibers together demonstrated the most effective performance in reducing the damage caused by projectile impacts. Hybrid micro steel fiber, hook steel fiber has the highest strength and ductility and resistance to penetration. Fracture toughness is more reliable ductility predictor, and crater area is a better metric determination than depth of penetration for ductility. Thank you very much for your patience.